Good morning. So today's example is related to the weight-volume relationship of soils. The reference is the Fundamentals of Geotechnical Engineering, 5th edition by Das and Sivakugan. A representative soil specimen collected from the field weighs 1.8 kilonewton and has a volume of 0.1 cubic meter. The moisture content as determined in the laboratory is 12.6%. We're given a specific gravity of 2.71. So from this given data, we are asked to determine the moist unit weight, the dry unit weight, the void ratio, porosity, and degree of saturation. So let us write the given values or the given data. We have the weight of the specimen is equal to 1.8 kilonewton and the volume is 0.1 cubic meter. A moisture content is given to be 12.6% and a specific gravity of 2.71. To solve for the first question, the moist unit weight, or this is denoted as gamma. The general formula is equivalent to the weight over the volume, and since the weight is already given and the volume is given, this is a direct substitution. We can just simply plug in the value, and this is 1.8 kilonewton divided by the volume, which is 0.1 cubic meter. And if you solve this problem, this is equivalent to 18 kilonewton per cubic meter. So to solve for the dry unit weight, we have a relation that the dry unit weight is equivalent to the moist unit weight divided by 1 plus the moisture content, and we have calculated the moist unit weight to be equal to 18 kilonewton per cubic meter. This is divided by 1 plus our unit weight is 12.6%, or this is equivalent to 12.6 over 100. And so we can get a dry unit weight of 15.99 kilonewton per cubic meter. Then for the next question, which is the void ratio, given a value of the dry unit weight, we can use the special case formula for the dry unit weight, and that is equal to gamma sub d is equal to g sub s, gamma sub w divided by 1 plus e. And from this relation, we can check the parameters if they are given. We have the gamma sub d is given, the specific gravity is given, the unit weight of water is known, and the only formula or the only parameter here that is unknown is E. So from here, we can solve for E, which is equal to the specific gravity multiplied by the unit weight divided by gamma sub d minus 1. So substituting these values, we can get 2.71 times 9.81 divided by the calculated unit weight dry, which is 15.99 minus 1. We can get a value of E, which is equal to 0.66. Then for the next question, which is porosity, since the void ratio is already known, we have a relation where we can solve for our porosity, and that is equal to E divided by 1 plus E. And we simply plug in the value of E, 0.66 divided by 1 plus 0.66, and the porosity can be calculated as 0.398. Lastly, for the degree of saturation, which is denoted as S, the general formula is the volume of water divided by the volume of voids. But we don't have the volume of water and volume of voids. But you remember, we have a certain relation that is very useful containing the other parameters, which are the water content, specific gravity, and the void ratio. If you remember that S is equal to the water content multiplied by G sub S divided by E. And we have the water content, the specific gravity, and the void ratio. So from here, we can solve for the degree of saturation. So water content is 12.6 or 0.126 multiplied by the specific gravity of 2.71 divided by E of 0.66. So this is to be multiplied by 100 so that we can get S in percentage. So from here we can solve for S, or the degree of saturation, which is equal to 51.7%. So that's it. We have solved for the moist unit weight, the dry unit weight, the void ratio, porosity, degree of saturation. Thank you.